Hello. A couple months ago I shared a video about a ping pong robot that I made, and I've been having a lot of fun with that, and it actually works quite well. But sure enough, after making it, I definitely found some things that I wanted to improve with it, and I actually just recently got a 3D printer, so I'm pretty excited to make some of those improvements, or maybe even a whole new one in the future. But in the meantime, because it'll be a lot of work to redesign it, but in the meantime there's some other things that I could improve, and I think the first thing was the circuit design. So the circuits in that original ping pong robot they're not messy, but I used two different breadboards and a bunch of jumpers, and it could be neater and could take up a lot less space. So I decided to take a stab at that by designing my first PCB. A PCB is a printed circuit board. It's basically, it's those silicon boards with wires and traces and components in them that you see on pretty much all electronics. So I decided that I could probably simplify the wiring a lot by doing something like that. And I didn't have any experience with doing this, but I found some good tutorials for a free open source program called KiCad. And those tutorials are on YouTube, and they're by DigiKey. So I'll link those down in the description, and I recommend you follow along with those. Coming up, I'm just going to show a kind of quick walkthrough of what I did, not totally step by step, but you'll get the idea. So let's go ahead and roll that right now. So a few weeks after sending away that design to the Osh Park website, I got something in the mail. And these are the finished circuit boards. And when you use Osh Park, they'll always give you at least 3, so the minimum order is 3. So even if you have a tiny thing, you're going to get more than 1. So here's what they look like. If I can make it focus, there we go. So yep, looks just like how it was supposed to from the design, and you can actually see the traces on there and make sure that they look right. Here's the 3, and you probably noticed that they have this interesting purple color, which is, I guess, unusual. I guess it's an Osh Park thing. And also, for some unknown reason, the next day I got this package in the mail, which had 3 more. And I have no idea why that happened, but I guess I'm not going to complain. But yeah, that must have just been a mistake. So the next thing I have to do is solder on all the connectors and the 3 resistors. So let's go ahead and do that. And here is what the final thing looks like after I've soldered everything on. There we go. So it's just got a bunch of header pins. So these ones over here on this side are for the servos. So the servos already have basically like a female header pin connector. And then for everything else I'll use these female ones on the board itself. And I did put in some extra pins for both sides really, more than I need, and the reason for that is because since I have all these extra ones, I figured I might as well have extra pins in case I want to use them in the future for something else. Let me show you how the Arduino goes on. So this is the Nano. It's quite small, and let me just plug it in here. There we go. Voila. So I think the next thing to do is test it out. Okay, so here is the PCB with the Arduino attached, and it's all installed in the ping pong robot now. So it does have kind of a lot of wires still, but they are all neatly arranged with some connectors, so they're very easy to take on or off. So that is much more organized than it was before. The potentiometers are all connected over here, the switches are connected here, and then the speed controllers and servos over here. And I also have this USB connected to the Arduino, and that's going to let me program the board and also monitor it. So what we're going to do right now is to monitor, and I have it set up to print out all of the values of the analog and digital inputs. So we can take a look at that by opening the serial monitor. And so the first 5 values, first 5 columns here are the potentiometers. So those are the analog inputs. Those should go from 0 to 1023. And then the last 3 are the digital inputs. So those will just be 0 to 1. So if I turn these That goes 0 to 1023 like it should. This one also, actually the second one doesn't quite go down all the way to 0. That's probably just means that pot isn't perfect anymore, but it'll be good enough. This one, as you can see, is the one that turns the robot left and right. So that servo is connected, so it'll turn, and you can see the number go up and down. Yep, so all of those seem to be working. And now the switches, when I turn that switch on, it starts the cycle. So, yep, those are all working as they should. So it looks pretty good. And I'm going to show you one more thing before we take it down to actually try it out with the actual ping pong table. Okay, the one other thing that I wanted to show you was a feature of this Arduino, which was one of the reasons why I wanted to get it, which I think I mentioned this already in the video, but this one has an inertial measurement unit built into it, and I can use that to monitor the pitch angle. So I want to show you that right now. So I have it now printing out the pitch angle. This is calculated using the accelerometer. You can get, if you just have a static pitch, that'll show up on an accelerometer due to gravity applying a force to it. So right now it says -2, which is probably close enough. I don't know if this table's actually perfectly flat, but anyway, if I tip it up, then it goes up to higher angles. But anyway, this looks like it's working. And so what this allows me to do is when I pitch the whole thing up when it's shooting the ping pong balls, then it'll adjust the flap open time so that it will be just open long enough to release a ball no matter what angle it's at. So that'll be a cool little feature. I had that before, but I had to do it manually using this dial right here. Previously I had to do it manually, so now it'll do it automatically, and I just have that dial as a little adjustment. So that should be quite convenient. Okay, it's time for one more final test, a live test to make sure it works. So I will plug it in. And turn it on. So far, so good. Let's turn up the frequency a little bit. There we go. And now if I tip it down, it should adjust the flap speed, and so just release one ball at a time. And now if I tip it up, all right, so that all seems to be working. I think we'll do one final test, which will be just me hitting some balls. So I hope you enjoyed this video. I think it was well worth learning how to make a PCB, and I'll probably do it again in the future, and you should try too. All right, bye.